Hey class, today's video is now kind of continuing what we were working on last time with radicals. I've got a couple warm-up problems here just to get us going and just to practice what we learned yesterday. So what I'd like you to do is pause the video and try these two square root simplification problems and then unpause the video and check your answer. Alright, see how you did? For problem A, we want to break up 40 into root 4 times 10, and root 4 is 2. So we get 2 root 10. 10 doesn't have any perfect squares that go into it, so we're done with that problem. For B, the best way to do it is to break it up into square root of 16 times 3, and the square root of 16 is 4. So we get 4 root 3. Now some people might start problem B by doing 4 and 12. So they might say, oh, I know 4 is a perfect square and it goes into 48. So you go 4 times 12 and you get 2 root 12. And that's okay to start, except that we have to keep going because there's a perfect square that goes into 12. 4 goes into 12. So I'd have to write 2 times root 4 times 3. And then I get 2 times the square root of 4 is 2 root 3. And 2 times 2 is 4 root 3. So you still get the same answer. Either way is okay, but we always want to try to find the biggest perfect square that goes into a number. Alright, so now let's go to the new stuff for today. Yesterday's video we learned about the multiplication property of square roots, and just as a quick review of that, I'll put that up on the side here. That multiplication one was square root of AB is equal to square root of A square root of B, or vice versa. And same thing with division. So here I have square root of A divided by B. So the whole fraction is inside a big tall square root. What we can do is we can split it up to square root of the top divided by square root of the bottom. Okay, it's a fraction with a square root on top and bottom. All right, so the way this works is it helps us simplify problems that have perfect squares in them, for one thing. So for problem 1, it's a big square root with 25 over 9 inside, so I can split it up into square root of 25 over the square root of 9, which equals 5 over 3. In problem 2, I get square root of 3 over square root of 64. Square root of 3 does not have a perfect square, so we just leave it. But square root of 64 is 8. And that's our final answer, root 3 over 8. Let's do 3 more problems here. So in number 3, what we'll notice is there's no perfect squares right now, 22 or 8. So splitting it up at this point doesn't make any sense. So you always want to try to reduce a fraction if you can. I can reduce this fraction, 22 over 8, by dividing them both by 2. And so let's see, when I do that, I get square root of, because I'm not doing anything with the square root yet, I'm just reducing the fraction inside. Divide them both by 2, I get 11 over 4. And I like that because 4 is a perfect square. So now I can split it up into square root of 11 on top and square root of 4 on the bottom, which gives me square root of 11 on top, that's not a perfect square, over 2. And that's my final answer, square root 11 over 2. Now 4 and 5 are actually doing the property in reverse. All right, so square root of 20 over 5, neither of those are perfect squares. But what I can do is turn this into square root of 20 over 5, which is, and if I do 20 divided by 5, I get 4. So square root of 4, which is 2. Okay. Number 5 is going to combine both of our properties from yesterday and today. So when we look at this problem, we have two things that we see here. We've got multiplication across the top, but we've got division going down. And when you do that, you can actually try to figure out what's the most efficient way of doing this problem. Okay, I could multiply the top, but now I have to do 6 times 18 and I have to figure out what that is, and then you do 6 times 10 is 60, and 6 times 8 is 48, so it's 108. So we just made that number a whole lot bigger. Whereas if we divide, we're actually making numbers smaller. So we might want to start this problem with division. So to do that, I'm going to try to get the biggest number and make it smaller. So I'm going to keep the root 6, but then I'm going to combine the 18 and the 2 into one big fraction. One big radical, I mean. What is 18 divided by 2? It's 9. So I get root 6, root 9. And root 9 I know is 3. So I get root 6 times 3. The 3's on the outside, so we usually put that first. So I'm going to put 3 root 6 as my final answer. Okay. I'm going to show you a different way to do that one. For that one, I could do the 6 divided by 2 first. So I gotta go root 6 over 2 times root 18. And the root 6 over 2 is 3, so it's root 3 root 18. But then I have to simplify the root 18. Root 18 is root 9 times 2, and that square root of 9 is 3. So I'd get a 3 on the outside from the square root of 9, but then I still have root 3 and root 2 on the inside. And what you do with those is, because they're both inside, we can multiply them together. I get 3 root 6, same answer. I think I like the first way better because we get the bigger number reduced faster. Alright, that is all for this video. Thank you for watching.